Okay, welcome. So last video we talked about what factors are, prime factorization. And we're going to use those terms when we're dealing with these things that are a little bit more important for some of the topics that we talk about later on. I know you've done these topics, GCF and LCM, in younger grades, and we talked about what those things are and how you find them. We're going to talk them at a little higher level, and so we're going to find them maybe a little bit using a little bit more math, reasoning, and logic. And that's going to help us deal with maybe numbers that we're not even familiar with, how we can go ahead and find GCF and LCM with them. So as a reminder, remember greatest common factor, GCF, right, is the largest whole number that divides evenly into two or more others. So it's the biggest number that goes into both, right, if you only have two. If you have more than two, then it's the biggest number that goes into, all three of the numbers or all four of the numbers or whatever. So that's the GCF. It's the greatest common factor, right? The LCM is the least or smallest number that's divisible by both or all of the numbers, okay? So both of the numbers have to go into it. And the names themselves, all right, sometimes students that don't have quite the grasp on it get them mixed up because the greatest common factor is actually usually smaller than the numbers themselves, and the least common multiple is actually bigger usually than the numbers themselves. It could be equal to one of the numbers, as we'll talk about that in a second. So we know what those are, right? Common factors are numbers that are factors of two or more given numbers. And so, easy example, all right, 20 and 16 have some common factors. 1, 2, 4, 5, 10, and 20, we said in the last video, are factors of 20. We look at the factors of 16, 1 times 16, 2 times 8, and 4 times 4. So 1, 2, 4, 8, and 16 are the factors of 16. And 1, 2, and 4 go into both numbers, and so they're common factors. And, we already knew this. We know that, well, 1 is a common factor for all numbers. 1 goes into every number. But 4 is the largest number that goes into both of those, 20 and 16. So 4 is their GCF, or their greatest common factor. 4 is the GCF. It's the biggest number that goes into both of these. It's on both lists, even though 1, 2, and 4 fit that need. All right, so let's examine these a little bit closer. So we have 20. I did the prime factorization of 20. I've got 2 times 2 times 5. Prime factorization of 16. 16 is one of those great numbers. It's all factors of 2. It's 2 to the 4th power. And so 2 times 2 times 2 times 2, or 2 to the 4th is 16. And you can write the prime factorization with exponents as 2 squared times 5, or 16 you could simply say is 2 to the 4th. And again, the common factors 1, 2, 4, 5, 10, and 20, 1, 2, 4, 8, 16, the common factors are 1, 2, and 4. And if we look at the prime factorization, so I'm looking here and here, right, they have some common primes. All right, 20 has 2 times 2 times 5. 16 we know is 2, 2, 2, 2. So they have a 2 in common. In fact, they have actually 2 times 2 in common. This has a 5. There's no 5 over here. So 2 times 2, or 4, right? 2 times 2 is the biggest number that you can make. It's a factor of each. And so that is the GCF. 4 is the GCF of those two numbers. I'm going to do another one here. If we take the numbers, let's take the numbers 48 and 90. We might not know that one off the top of our head. Maybe we do. I don't know. All right, so again, the factorization of 48, if I did that, I would probably do the two numbers closest together. So I break it into 6 times 8. 6 becomes 2 times 3. 8. Now 8, I know ends up, it's 4 times 2, and it does end up being 2 times 2 times 2. And we probably know this, right? We know that 2 to the third power is 8. So kind of when I get from 48, if I look at it's 6 times 8, I'm basically done because I know 6 will break into 2 times 3. 8 is 3 twos. So it becomes 2 times 2 times 2 times 2 times 3. Or 2 to the fourth times 3. 90, again, you could do 2 times 45 and continue breaking that down. The Bossert method would be to break it into the numbers closest together, two factors that are closest to the middle, 9 times 10, and then that usually is the least number of steps. And you can see that 9 is 3 times 3, 10 is 2 times 5, and now these are all primes. So I'm done. It's 2 times 3 times 3 times 5. And then if I look at them together, all right, by the power of Bossert, I can kind of stack them, right? 48 is 2 times 2 times 2 times 2 times 3. Oops, sorry. 90 is 2 times 3 times 3 times 5. And if you look at what they have in common, right, they each have a factor of 2. And there's no other common factor. Oh, there's a 3, and they each have a 3. So they each have 2 times 3 in them. So their GCF will be 6. So the biggest number that goes into both is 2 times 3 or 6. Alright, and then if I think about multiples, right? I know multiples of 20 would be 20, 40, 60, 80, 100, 120, 140, 160, 180. Multiples of 16 would be 16, 32, 48, 64, 80, 96. This becomes harder with numbers like 16, or I'm adding 16 each time, right, to get to the next multiple. And I think this is how I would have tried to find the least common multiple. I'd just start writing out multiples of 20, multiples of 16, until I got to one that was in common, which is, it looks like 80, right? They both have 80, and that's the smallest multiple that they both have, all right? And it's 80. So 80 would be the LCM. That's nice. But I want to notice that 20 times, all right, the number times, it's the 1, 2, 3, fourth multiple of 20 is 80. So 20 times 4 equals 80. And 16, if I take a look at 16, it's the 1, 2, 3, 4 fifth multiple of 16. So 16 times 5 equals 80. Now if I go back and look at, all right, not this one. There you go. If I go back and look at the prime factorization, remember, to find the GCF, there was 2 times 2. See, I've circled that. What's left over from the 20? What didn't I use? What part is not part of the GCF? Well, 5 is. The 5 is not part of the GCF. And what part of the 16 was not used? Well, these two 2's were part of the GCF. So 2 times 2 are 4 is not, it's the leftovers, it's not part of the GCF for 16. And so if I took 20 and I multiplied it by these 2's that I didn't use, 2 times 2, 20 times 4 is 80. Or if I took 16 and I multiplied it by the 5 that wasn't used out of the 20, 16 times 5 is also 80. It's the number of multiples it takes to get to the LCM, right? 4 was the leftover part of 16 that wasn't part of the GCF, so 20 times 4 was 80. And 5 was the part of 20 that wasn't used in the GCF, so if you take 16 and multiply by 5, I get 80. And it's not a coinky-dink. All right. Again, what is part of the GCF, or what is part of both numbers? That's 2 times 2. The 5, right, is the leftover factor for 20 that's not part of the GCF. The GCF is 4, or 2 times 2. 20 is 4 times 5. 16 is 4 times 4. If you take the fifth multiple of 16, all right, 5 times 16, that's 80. If you take the fourth, 2 times 2, if you take the fourth multiple of 20, 20 times 4 is 80. That's how you can get to the LCM. You take the leftovers of one number, right, and multiply it by the opposite number, you can get to the LCM. Or if I take the leftovers of 16, that's 2 times 2 or 4, multiply that by the 20, I get the fourth multiple of 20, or the fifth multiple of 16 gets me to the LCM. Alright, so those are the factors of, if I had to find the factors of 56 or 144, I could list out the factors. This is a list of factors. It's not the greatest common factor or the prime factorization. The greatest common factor, I have to look at these, make sure I don't miss one. 8 goes into both. Is that the biggest one? Is 28? No. 56? No. So 8 is the biggest number that goes into both. Now again, to create this list, it may take some of us a long time. So the better way is to use prime factorization. So 56 is 2 times 2 times 2 times 7. 144, we did this, is 4 times 3 and 4 times 3. So 2 times 2 times 3 times 2 times 2 times 3. So this is the factorization of 144. And again, if we take a look, what do they have in common? 3 factors of 2. They each have 3 factors of 2, or 2 times 2 times 2, or 8 in common. So the GCF is 8. Right? What's the LCM? Well, the LCM would be the smallest number that they both went into. If I want to use the fourth grade method, and this is what I call it, I'd have to start listing out multiples of 56. So I have 56, 112, 168, and oh god, this is horrible. If I add 56 to that, I get 224, I think. 224. And then, oh geez, what would the next be? Add the 56 to that. That's 280, I think. All right. All right. What happens if I get one? Let's see. 336. Okay. That one wasn't so bad. 380, 392, 392. All right. And again, how many things people think? Well, maybe that's enough. Maybe I don't need to do anymore. Okay, so 144. Okay, all right. 144, 288. Oh God, this is horrible. 3, 4, 4, 432 will be the next one. Okay, 576. I hope. 6, 7, 20, 720. Okay. Well, I'm ahead here, so let me go back over here and see if maybe one of these is here. So I add 56 to this, and I get 48. Okay, add 56 to that, and I get. Alright, anybody? I hate this game. This is the worst game ever. So you see that doing this with numbers 56 and 144, those aren't unreasonable numbers. Now, so right, I mean, I could go a long ways. What happens if I make a mistake somewhere along the line in here? I add wrong. I mean, I'm in big trouble. There's no chance I'm going to get it right. So this is very difficult with numbers that are, slightly bigger than what I'm used to, or not part of my times tables. However, if I used my method from before, if I take 144, and I usually choose the bigger number, so if I take 144 and multiply it by 56, but I don't need to multiply by the this part of 56 because 2 times 2 times 2 is already in 144. I just need to multiply it by the leftovers, and there's only one factor that I didn't use. So if I take 144 and multiply it by 7, right, I'm going to get the answer. I'm going to get the LCM. It's the 7th multiple of 144 because I've used all of the factors in 56, 2 times 2 times 2, except for the 7. So it's the 7th multiple of 144, or it would be the, in this case, the 18th multiple. 2 times 3 times 3 is 18. 18th multiple of 56. All right, so that's all I have to do. 28, 33. I get that, do that right. 28, 28 carry the 2 is 30. 3 is 1,008. 1,008 it was. All right, is 18 times 56. All right, I'm going to cheat. Let's see, how do I do that? Interactive calculator. All right, what do I need to do? 18 times 56. I hope it's 1,008. Oh, good, yes. 1,008, or if I did 144 times 7. 1,008. So going back to this screen, I'd have to go ahead and I'd have to 1, 2, 3, 4, 5. I have to do 2 more multiples of 144, and I would get 1,008. And I'd have to do 18 multiples of 56. Again, you can imagine listing them out that's horrible. No one wants to do that. Now what happens if I have 2 monomials? Now this seems crazy. This seems like, oh my gosh, this is like impossible stuff, the GCF of these two. But in fact, it's really not. Because I don't know the values of x and y and z, right, I can't break them up into anything more than they already are. So the factors of 20, the prime factors of 20, x, y to the third z is just going to be the prime factors of 20, which would be 2 times 2 times 5 if you did the factorization. And then x, and then there's 3 factors of y. All right, 3 factors of y and a z. All right. And for 24, 24 is 8 times 3, so I think we know how that turns out. 8 is 2 times 2 times 2. And then times 3 is, and then we've got x squared, so that's 2 factors of x and 2 factors of y. Now, I like to stack them, not them, still not them. Yay. All right, I like to stack them one on top of the other so I can easily see what they have in common. And you can see they have 2, 2, all right, an x and 2 y's in common. So their GCF is going to be 2 times 2 times x times y times y. 2 times 2 is 4. X and y times y is y squared. And that's the GCF. That's it. 4xy squared. The LCM? Well, what's left over? What did you not use? All right, what was not part of the 20 x y to the third z? What did I not use? I didn't use the 5, and I didn't use this y and z. So I really just need to take this number and multiply it by 5yz to get 120 x squared 120 x squared y to the second here times one more y is y to the third, and then times z. And that's the LCM. If I took this number, let's do this in blue. If I took this number, this monomial, and I multiplied it by the leftovers of the other number, I didn't use this 2 or 3, so that's 2 times 3 is 6. And I didn't use this x. So if I took this number and I multiplied it by 6x, what would that give me? Well, it would give me 20 times 6 is 120. X times x is x squared, y to the third z, and 120 x squared y to the third z, that's the LCM. So it doesn't matter which way you do it. Leftovers of one number times the opposite number. Essentially, you're multiplying them together, but you're not using the GCF twice, you're only using it once. So to recap, to find the GCF, we're going to use all common prime factors from the factorization. To find the LCM, we're going to multiply one number, or a monomial, times the leftovers of the other number that are not part of the GCF. Right, and I'd like you to give this a shot. Right, I'm going to pause it, give it a shot, and then come back when you're done. I want you to find the GCF and the LCM of these two monomials. Alright, so I did the factorizations, and you can see in blue underline, the common factors are they both have a 5, both have an x, they both have y, y, y. So the common factor, the greatest common factor would be 5 times x times y to the third, or 5x y to the third. So that would be the GCF. The LCM would be multiply one number times anything that's not used, or the leftovers. And really, the easiest one to do would be to take this monomial and multiply it by, right? The only thing that wasn't used over here from the 15xy to the third is the 3. So if you just take this and multiply it by 3, you get whatever that is, 345 x squared y to the fourth. And that would be the LCM. We're going to go ahead and use that we're going to apply it here, but we need to be able to do those skills. Factorization, find the GCF, find the LCM. All right, thank you. Namaste.